All right, can you see this page now?
Yeah.
Yeah.
All right, so it looks a lot like, let me see if I can do that again. It looks a lot like page 437, but the questions are a little different. And so it's extra practice, and that's why I wanted to go over it. If you look at, for example, let's look at the first 6 problems, okay?
Okay.
If it says, the directions are right above it, letter A. It says, write a proper fraction for the shaded portion of each figure, okay? Looking at number 1, what would you write as the fraction?
In the page 437 or in the picture?
On the picture in my screen. Because Mona, you might have this because you have the Kaplan book, but Fatima doesn't. So that's why I'm showing it to you guys. Just looking at number 1.
You want the answer, you mean?
Yeah, what would you put for the answer? And it keeps going away. I don't know why. I apologize about that.
I think that for number 1, it's
Sorry.
it's
It
Yeah,
keeps giving me comments, and I'm like, I don't want comments.
okay. 3 out of 4, out of 5.
3/5. Mona, do you agree?
yeah.
3 out of 5. Very good. 3/5. In the last video, I think one of the last videos that I posted about how to pronounce fractions. So when it's 1, if it was 1 shaded over any amount, like let's say there was 5 boxes and only 1 was shaded, we would say 1/5. It would end with a TH, right?
1/5?
Yeah, 1/5.
Oh, okay.
But here in this example, we have more than 1 box shaded, right? Plural. So we'd have to add an S for fifth. So we would say 3/5.
3/5.
Because we have more than 1 shaded. Does that make sense?
Yeah.
Yeah.
If it was 2/5, it would be the same. 4/5, it would be the same. There would be an S at the end of fifths. Okay?
Okay.
All right. So, good. We got number 1. Let's keep going. Number 2. Mona, what do you think for number 2?
Where's number 2? Okay. 2/4.
2/4. 2/4. Very good. Now, 2/4, can I reduce that?
Yeah, 2 out of 4.
2 out of 4, but I can reduce it, right? Meaning I can make that fraction smaller,
Yeah.
right? And the reason I know we can do that is because 2 is divisible by both 2 and 4.
Yeah.
So if I divide 2 by 2, I get 1 for my numerator. And if I divide 4 by 2, I get 2 for the denominator. So now my new reduced fraction for this figure is 1/2.
Yeah, 1/2.
Does that make sense?
Yeah.
Okay, great. Let's look at number 3.
1, 2, 3. 1/3.
1/3, Fatima says. Fatima Al-Fatlawi, are you with us?
Yes, I am.
Welcome, welcome.
Thank you.
You're welcome. Okay, so what I'm showing right now, I'm sorry, ladies, just give me 1 second. So what I'm showing on my screen now, what you are seeing, Fatima, is a page from another book that's similar to the fraction basics on page 437 in your book.
Okay.
Okay, so it's just more practice, but it's from a different book. Okay, so number 3, Fatima K says it's, give me your answer again, Fatima.
2/3.
Oh, 2/3. Okay, she fixed it. She fixed it. Yes. And it may be because it's hard to see on my screen. I'm sorry about that. Okay. So yeah, there are 2 bars out of 3 shaded. So we would say, how do you pronounce that?
2/3.
2/3. 2/3. Yes. Give me 1 second. I apologize. Give me 1 second. Normally I don't get this call, so I have to take it. I just need 1 second. I'm sorry.
It's okay.
Hello? Hello?
Yes.
Yeah.
I apologize about that. Okay. So 2/3. And I don't know if you gave me the answer a minute ago, Fatima. but
Yes.
2/3 would be how we would pronounce it. Very good. So again, we were talking a minute ago for the people that just joined. We were talking a minute ago. We said when we're pronouncing a fraction and we're trying to read it, if we have, for example, 1 bar shaded out of 3, we would say 1/3, right? If
Yeah.
it's more that are shaded, like plural number, then we would have to add an S to the denominator. So we would say in this case, 2/3. Does that make sense?
Yeah.
Okay.
Yes.
All right. Let's take a look at number 4, and I'm going to have to keep canceling over here while I do this. Can you guys see it? I'm going to zoom back. Number 4, can you see it?
Yes.
Okay, what do you think for number 4?
1, 2,
It gets a
Is it-
little harder when there's more than one figure.
Is it the 37? Or like,
Ooh. When do you think that's 3/7?
mm,
Okay, you're close. You're close. What made you think it's 7?
because that's 7 shaded and 3,
Okay,
I don't,
and actually, the 7 is the total number of parts. Do you see if I counted each part? I have 1, 2, 3 in each circle.
mm-hmm.
So we have 1, 2, 3, 4, 5, 6, 7 of the parts are shaded.
Yeah.
So that would be my numerator. 7 would be the numerator.
3/7.
Not 3/7, 7/3, because 7 are shaded. And where do you think the 3 in the denominator came from?
The number of the circles.
I'm sorry. What is it?
The number of the circles.
It's actually not the circles. In this case, it's not going to be the circles. It's going to be the parts that make up the circle, each circle. How many
know-
pieces, equal pieces, make up each circle? 3,
Yeah.
right?
Mm.
So if we're looking here, we have 1. Can you see what I'm doing?
Yeah.
Okay, so we have 1, 2, 3. There are 3 equal parts in each circle. So those equal parts, 3, becomes the denominator. And the number that are shaded in is 7, and that is the numerator.
Is that 7/3?
7/3, yep.
You know why I told you that third 7? Because I thought the small number will be in the top every time.
Oh, yeah, and that's a good question. It's not always that it's going to be the numerator is smaller than the denominator. Remember, when we have a numerator that is greater than the denominator, what do we call that? It's in the directions. Look at B.
Excuse me, can you say me which page?
So this is not a page that you have.
Okay.
Yeah. It's a page from a different book,
Okay.
from another GED practice book.
Okay.
Yeah. I will send it to you guys. I will send it to you guys on Remind. Okay?
Okay. Thank
Yeah.
you.
Yeah, no problem. So if we look at number 4 again, we were saying that sometimes the numerator is greater than the denominator. And do you guys know what that's called?
No.
How can I know? How can I know the, like, when I do the numerator and the top and the, like, switch?
Right. So it's the shaded part. Whatever is shaded will be your numerator. And sometimes that number is greater than the denominator.
Oh, okay.
Yep. So whatever is shaded is your numerator.
Okay.
Okay. Here, the number shaded is 7. There are 7 parts shaded.
Yeah.
And I'm looking now at each circle to decide how many equal parts it's divided into. And in this case, each circle is divided into 3 parts. So that 3 is my denominator. I'm going to see if I can write that on the screen here for us. So give me just a second. Can you see that?
Yeah.
7/3?
Yeah.
Okay. Now, this is called an improper fraction. And I'm going to see if I can put that on this side. Improper. Okay, an improper fraction. And an improper fraction is one where the numerator is greater than the denominator. If you want to take those notes, write those notes down.
Okay.
Okay,
Yeah.
I'll give you a minute. So the opposite of a improper fraction is proper. In English, when we say something is proper, it's like it's correct, right?
Yeah.
If it's improper, it means it's wrong, right? That's why when we look at a fraction like this, like Muna said, she thinks it's wrong because the numerator shouldn't be greater than the denominator, but it can happen. We call that an improper fraction.
Okay.
So I'm glad you asked that question. Okay.
Okay.
Now, so part B says for number 4, 5, and 6, we're supposed to write an improper fraction and a mixed number for the shaded portion of each figure. So we did the first part, right? We
Yeah.
wrote 7/3, and that's our improper fraction for number 4. Now we have to turn this improper fraction into a mixed number. Okay, I'm going to erase what I have here. Okay. Mixed number. Let me know if this is not clear or if you have any questions. Mixed number. This is where we're going to have a whole number,
Okay.
and a fraction next to it. That's called a mixed number. So for example, 1 and 1/2. That is a mixed number.
Okay.
Okay. Anytime we have an improper fraction where the numerator is greater than the denominator,
Mm.
we can turn it into a mixed number, especially if the directions require it. Usually we don't like to keep fractions improper. Usually the way to fix that is to turn it into a mixed number. Okay, with a whole number in front of it and a fraction.
Okay.
Okay, so
Okay.
the way to get the mixed number now is to do some division. I have to ask myself, okay, I'm going back over to the left side now. 7/3, I'm going to divide. How many times can I divide 7 by 3? How many times can 3 go into 7? That's going to be my whole number and my mixed number. Stop me if you have questions, okay? And we're going to do this together. So I know 3 can go into 7 2 times without going over, right?
Yeah.
Because 3 times 2 is 6. I can't do 3 because 3 times 3 is 9, and that's too much.
Yeah.
Mhm.
Mhm.
So 3 can go into 7 2 times without going over. Now, what's remaining is going to be your numerator. What is remaining when I multiply 3 by 2? I get 6. What's left? 7 minus 6 equals
1 and 3.
1. Does my denominator change?
3, no.
No. The denominator will not change. Going from an improper fraction to a mixed number, the denominator stays the same. Okay, and I'll show you one more time how we did that.
Okay, you divided 17 by 3. It's
7.
2.
Yes, I'm going to do it on this side. Ready?
And then you multiply. I don't know.
Do you see that? Can you see my screen now?
Yes.
Okay.
Yeah.
So again, we're going to say 7 divided by 3. We said 2. 3 times that 2 is 6.
Yeah.
Subtract them, and what do we get? 1. This one is now my what? What is it?
What?
Divide.
What? What?
The numerator.
Numerator.
The remainder is the numerator. So this one that was left or remaining became the new numerator for the mixed number. What about, let me see if I can get rid of this. What about the 2 up here for our answer? What about this? What did that become?
It's gonna be 1/2.
No. What did this 2 become? This became the whole number of my mixed fraction. This became the whole number. Look. See it?
Mm-hmm.
Does that make sense? So this 2 became the whole number. And this 1 became The numerator. Did the 3 change? No, the 3 was the same because it was the denominator that we started with.
Okay.
Let's try another one, okay? Let's look at number 5. I'll give you a minute to copy down what I have on my screen. And then we will look at number 5. Let me
I
know when
only
you're
see
ready.
the first page.
What's that?
I can see what you write.
Oh, you can't see what I write?
Mm.
Uh-oh. All of you can't see what I write?
No.
Oh, I thought you could see what I was writing. I'm sorry.
Mm.
Okay, 1 second. I'm going to try to see if I can share it with you one more time. Okay. Oh, it deletes it. I see. Okay, I got a better idea. So give me 1 second.
Okay.
I had a board. Where did it go? Okay. Can you still see my screen?
Yes, I can.
Yes.
All right. Let's do it this way, okay?
Mhm.
I'm going to try this again. And please tell me if you can see what I'm writing. What do you see now? How about that? What do you see right now?
The page.
A white page?
White
Yeah.
page.
Blank
Yeah.
white page. Okay, great.
Yeah.
All right, I'm going to do it one more time. So we had 7/3. That was our improper fraction, right?
Yeah.
And then we had to take this, and we're going to write it right here again. Improper. What's an improper fraction again? Remind me. Do you remember?
Improper fraction.
Yeah. What does it mean for when it's an improper fraction? What's greater, the numerator or the denominator?
The numerator.
The numerator, exactly. So the numerator is greater than the denominator in an improper fraction. Okay?
Like the top and the bottom, right?
Yes, this is our numerator up here.
Mhm.
Okay. That's our numerator. And this is the denominator. Okay, in an improper fraction, we have a numerator greater than the denominator. All right, so now I have the 7/3 improper fraction, and I want to try to turn it into a mixed number. And we said the way to do that was what? What was the way to do that?
Divide.
Division, exactly. Can I delete this? Can I erase this?
Yeah.
Yeah.
Okay, we got it?
Yeah.
Mhm.
Okay, let's erase it. So I have more room. Okay, so now going back, we had 7/3, and then we're going to do some division. We're going to say 7 divided by 3. We're actually going to divide the fraction that we have.
Mhm.
Okay, how many? 7 divided by 3.
Yeah.
So we're going to write it out and do the long division.
Yeah.
Now, 3 can go into 7. How many times?
2.
2.
2 without going over. Because if I said 3, remember that's 3 times 3, which is 9. That's too much.
Mhm.
So now 3 times 2 is
6.
6. I'm going to write that right there. We're going to subtract. 7 minus 6 is
1.
1. And remember, this 1, all these numbers mean something, so we're going to go back and write it out. I'm going to change the color. Let's see if I can change it here. I'm going to make it blue, my mixed number, okay?
Mhm.
This 2 becomes my,
Denominator.
no, my whole number.
Whole number.
The whole number in the beginning of my mixed number. So now it's 2. And what's the numerator?
1.
1. Yes.
Mhm.
So the remaining, or the remainder, okay? Whatever's remaining becomes the new numerator. And what is the denominator of my mixed
3.
number?
The 2.
3.
Somebody said it.
3.
2.
3. Remember, why is it 3? Somebody said it. Why is it 3? Because look,
Dividing. Yeah, it divides 3.
because we're not changing the denominator.
Yeah.
We don't change it. Please write that down. We will not be changing the denominator.
Okay.
From an improper fraction to a mixed number, we will not change the denominator.
Okay.
Okay? Also, just one more time, the answer that we got, right? The answer that we got, the whole number answer that we got became
Two.
the whole number of our mixed fraction.
Mhm.
And the remaining numbers became the numerator. Whatever was left became the numerator.
Okay.
Okay, let's do another one for practice.
Okay.
Does everyone have this written down?
Yeah. Okay.
Okay.
No.
Questions?
No. Thanks.
No.
Okay. Let's go to the page that we were on. We're going to share it again. Let's see if I could find it. Okay. All right, we're back on number 5. Can you see number 5 now?
Yes.
All right. Fatima
Yeah.
A, do you want to try number 5?
Yeah.
Okay, tell me what you think would be the first part, the improper fraction, because we have to find 2 answers for these problems. We have to find the improper fraction. We have to write that down. And then we have to write that as a mixed number. So what would you tell me is an improper fraction for number 5?
7, 4, divide 4.
For 1, 2, 3, 7, you said?
Yes.
7 over 4.
Over 4, yeah.
Okay. Where did you get 4 from? Is it because you see 4 squares?
Yeah.
Yeah.
4.
Yeah, and it looks like it would be 4 squares, but remember the denominator is going to be, in this case, it's going to be 2. It's how many parts each square is made up of. Does that make sense? So each square is made up of 2 pieces.
Yeah.
So that is your denominator. The 2 is your denominator. But the 7 that you said is correct. There are 7 parts shaded. So that is your numerator. The
Okay.
denominator will be 2.
Why
Yeah.
two? Because everyone has 2 parts, or
Exactly. Every square has 2 parts.
oh,
Remember back in number 4, the denominator was 3. And it was
Okay.
3, not because there are 3 circles. No.
because
The
has
yeah, go
3.
ahead.
Okay.
Go ahead, Mona. You were explaining it. Because why?
Because number 4, we say every one has 3 parts.
Exactly. Every circle has 3 parts. So 3 was our denominator in that problem. And now we look for the number of parts in each square for number 5, and we see 2. Does that make sense?
Yeah.
Yes.
Yes. Is there a question?
I get you.
I don't get it.
Okay. So I'm going to try to draw it on the other screen. Hold on one second. Pause the sharing. Okay, are you with me?
Yes.
You see my blank page?
Yeah.
Okay.
Yeah.
All right, I'm going to draw it out for us. Okay. Can you see that?
Yeah.
Yeah.
They're not perfect, but you get the idea, right?
Yeah.
Okay.
Thanks.
Yeah, no problem. Okay, so now we have 4 squares.
Yes.
I see 4 squares, right?
Mhm.
But we're going to look at how many parts each square is made up of. So what would you say? How many parts?
2.
2.
2.
Yeah.
And that's going to be your, oops, wrong one.
2 over 4 or
No,
4 over
no.
2.
Oh, I keep choosing the wrong thing. Hold on one second. 2. 2. And it's very light. I don't know why it makes it very light. 2 is going to be my denominator because each square is made up of 2 parts. So that is my denominator.
Okay.
Now, let me see if I can do one more thing. I'm trying to color it in, and I don't know if I'll be able to. We'll just use this for now, okay? So pretend that these boxes are shaded. Shaded parts. Right? Those blue boxes inside of the triangles, those mean that they're shaded in. That's what I'm going to count. The shaded part is going to be my numerator. So how many shaded parts do you see?
7.
7. So that will become the
7.
numerator.
Mm.
Does that make sense now?
Yeah.
Yeah.
Okay. So this is what? Is it my improper fraction or my mixed number?
Improper.
Proper fraction.
Very good. Improper fraction. And it looks like an improper fraction, right? We have our numerator greater than the denominator.
Yeah.
Okay.
You
Now I
have
want
the
to turn this into a mixed number. Why don't you guys try it and tell me what you get?
3.
I heard the whole number, 3. Fatima, you said it, I
Yeah.
think. Good. That's the whole number.
Yeah. And numerator is 1.
Very good. Numerator is 1. Not a very good one. Hold on.
Denominator is 2.
That wasn't a very good one. Let me redo it. Hold on. There we go. And 1. Okay, 1. And what's the denominator?
2.
2. Very good. Very good. Ladies, is that what you got?
Yeah.
yeah.
Very good. Very good. Remember, it's the same way we did number 4, right? 2 can go into 7 3 times without going over.
Yeah.
And 3 times 2 is 6, right? What's remaining from when we take 6 away from 7 is our numerator, right? 7 minus 6 is 1.
Yeah.
And the denominator is the same. It's the same. Very good. Any questions about this so far?
No, thank you.
Okay, great. Let's go back to that page. Hold on one second. Uh-oh. Clear all my drawings. Okay, we're going back. All right, we're back. Okay, number 6. What do you guys think for number 6?
6.
I'll let you try number 6, all of it on your own. I'll give you a couple minutes, and then you'll let me know what you get. Okay?
Okay.
Is that 15 over 4?
15 over 4. Muna says 15 over 4. Let's give everybody a minute to see if they get the same thing.
15 over 4.
Who was that? That was Fatima A. You think
Yeah.
15 over 4 as well? Okay. What about you, Fatima K?
Okay, Mama, yalla. How we gonna put 15 over 4? And number 5 we put.
So remember, count the shaded parts first, Fatima. The shaded parts, how many do you see?
4.
Shaded. The whole thing. Pretend it's all one thing. How many shaded
15.
parts?
15.
15. So yes, 15 is the numerator. And remember, now look at each square and say how many pieces is each square made up of?
Oh, okay. 15 over 4, yeah.
15 over 4. So we all agree?
Yeah.
Excellent. Very good. 15 over 4, that's my improper fraction for number 6.
Yes.
What would be the mixed number for this problem?
We're gonna do 15 divided by 4. It's gonna be 3.
Okay.
And
3 over 4.
Oh, somebody said it. So I got an answer from all of you, I think. So we agree it's 3 3/4?
Yeah.
Let's go over it. Let's do it together one more time just to make sure. Can you see my screen, my blank page?
Yes.
Okay. So you guys told me, we're going to do it back this way. We got 15 shaded parts over how many parts each square was made out of, and it was 4. Not made out of, but made up of 4. So that's my improper fraction. Now I'm going to do some division, right?
Yeah.
15 divided by 4, just like the fraction tells us. 4 can go into 15 how many times without going over?
3.
3. And 3 times 4 is
12.
12. So we're going to subtract those. What's 15 minus 12?
3.
3. Very good. Remember, this number at the top becomes what?
It's the numerator.
Becomes the whole number.
Number, yeah.
The whole number. Okay, the whole number. And this number down here, this 3, the remaining 3, becomes what?
Numerator.
Numerator. Excellent. And does my denominator over here change?
No.
No.
No. Very good. Are we getting the hang of it? Are we getting the hang of it? Is it becoming easier?
Yeah.
Yeah.
Very good. Very good. Okay, I'm going to leave this up for you to copy it if you want. And then we're going to do one more from our green book. Okay, ready?
Yeah.
Muna, are you there? Muna,
Yeah.
is it Muna M? Somebody joined, I'm not sure who. Okay. All right, I'm going to erase this. I'm going to clear it. And we're going to go back with our mouse. Would you like to try more examples of turning improper fractions to mixed numbers on this page that we're looking at?
Mm-hmm.
Okay, why don't we try that then? Let me try to see if I can make this bigger for you. All right, how is this? Letter C, can you see letter C?
Yeah.
It
Yeah.
says write improper fractions as mixed numbers and mixed numbers as improper fractions.
Okay.
Okay, so what I'm going to do is I'm going to mute your microphones and I'm going to let you work on number 7
Mhm.
and number 10.
Okay.
Okay, I'm going to mute the mics. Somebody's bird. Oh my goodness, sounds so nice.
مقتدى. Hi, Miss Miriam.
Hi, Mona, how are you?
Hi, I'm good. I'm sorry, I thought you were not like no voice on the chat, so to make
Yeah,
sure.
yeah, it's okay. No, you're fine. I was going to mute the microphones, but hold on, give me a second. I don't seem to know how to do that now. I don't know why.
You can mute it from
Oh, I
her.
see it. Yes, yes, I see it now. Okay. All right, you should be able to hear me.
Yes.
Please, Mama.
Remember to try to do number 7 and number 10 that you see on the screen, please. Try those and then we'll talk about them.
Okay.
Okay. If you'd
What
like
number?
to try more, go ahead. We're going to talk about those two.
What number, Miss Mariam?
Number 7, which is
7.
17 over 3. So you're going to
Okay.
turn that improper fraction to a mixed number. And number 10, which is 5 and 2/9. You're going to turn that mixed number into an improper fraction.
Okay.
Okay?
Mm-hmm.
Are we ready? Oh, let me take it off. Hello? Hello?
Yeah.
Okay. I should have muted my mic too. Okay. So what did we get for number 17? What did we get for number 17? 17 over 3.
Is that 5/3?
You said 5 over 3, Muna?
Yeah, I think. I'm not sure.
So for that improper fraction, 17 over 3, in order to turn it into a mixed number, I need a whole number and a fraction.
3.
Let's go back to my page here and let's write it down.
Whole number is 5.
2/3.
5 2/3,
Yeah.
Fatima K says.
Yeah.
Fatima A, you agree?
Yeah.
Okay, we're gonna figure out how we got that. Okay? Do
Okay.
you want to tell us? Fatima A, do you want to tell us how you figured out 17 over 3?
Divided.
You divided, right?
Yeah.
17 by 3, right? Everyone can see my screen?
Yes.
Okay,
Yes.
good. So 3 can go into 17 how many times without going over?
5.
5. What's 3 times 5?
15.
15, very good. 17 minus 15?
2
2.
0.
What does this 5 become?
is whole number.
Whole number. Very good. I'm going to change the color. Let's do pink. Can you see it? Can you see that?
Yeah.
Yeah.
All right. So the 5 became the whole number. And what about this 2 right here? What did the 2 become?
Numerator.
Numerator. Excellent. Right? The 2 became a numerator. That's the remainder. Whatever was remaining became our numerator. And what does the denominator become?
3.
Or what is it?
3.
3, right. It does not change. Keep that in mind. The
Okay.
denominator does not change.
The denominator
An
of the
improper fraction to a
right?
mixed number, and the other way around, from a mixed number to an improper fraction. Mona, did you have a question? Mona
Yeah,
S?
the denominator is still same thing every time.
Yeah, when we're doing improper fractions and mixed numbers, the denominator should stay the same.
Okay.
Okay, whether I'm going from, it doesn't matter which one I'm going to. If I'm going from improper fraction to mixed number, it's going to stay. And if I'm going from like the other way around, it's going to be the same.
Okay.
Okay. All right. Questions?
No, thanks.
No. Okay, I'm going to delete, I'm going to clear this and we're going to look at the other problem that I wanted you to try, which was number 10.
Okay.
Okay, number 10 was a mixed number, 5 2/9. So let's write that down. We had, bless you, whoever
Bless
that was.
you.
5 2/9. Okay, how do I turn this into a, how do I turn this mixed number into an improper fraction? What do I got to do? Do you remember? What do I do here?
We do times. Yeah.
Yes, yes.
Multiply 9.
We have to multiply 9 times 5, the denominator times the whole number. And
Yeah.
then what do we do up here?
Add.
Add. So what's 9 times 5?
40.
45.
45, right?
45.
Plus 2 is
47.
47. Very good. So that 47 becomes the numerator of my improper fraction now.
9.
Okay, and 9, exactly, 9, because remember the denominator stays the same.
Yeah.
Does everyone understand how we got this 47 up here?
Yes.
Yeah.
Okay,
Yes.
okay. So again, we multiply the whole number by the denominator, and then we add the numerator. That gives us our total for the numerator. Okay.
Mhm.
No,
right.
no, no.
Um.
My book. My book.
All right. Really quickly.
Please, Miss Mariam, don't delete it. Just
Yeah. No, I'm gonna keep it on for a second. Go ahead. In
In
your book,
Yes,
bless you,
Mhm.
on page 439. Do you see that? Page 439.
Yeah. Yeah.
Okay. This is kind of what we were just working on. I'm gonna give me just 1 second. Sorry, I remembered to mute it, but I didn't remember to stop video. Sorry.
Which page, Miss Mariam, please?
I'm sorry.
Which page?
We're on page 439. I wanted you to take a look at, so they showed you what we just did. They showed you again on number 4. Do you see that?
Yeah.
Yeah.
It says 7/4 equals, and then they divided, right? They divided 7 by 4, and they got a whole number of 1. What was remaining was 3. That became the numerator, and the denominator is 4. So if you did not try this page, please do that and send me a picture of it. Some of you already did it.
Yeah.
Okay, if you sent me a picture of it, great. Some of you maybe did it but did not send me a picture. So I can give you credit for the time that you spent on it. Please send me pictures, okay?
Okay. Okay.
Yeah, whatever you work on in math especially, send me a picture and I'll give you credit for the time you spent doing it.
Okay.
I can send it back.
One more time.
I can send it again and give me another credit.
No, Fatima, I think I got yours. I think I gave you credit. Nice try. Okay. I also had assigned page 440. Let's go to page 440, equivalent fractions. Okay. Equivalent fractions. Were there any questions about these? How to cross multiply them? So let's look at, Fatima, there was one you asked me about once. Do you remember? Was it number 12?
Yeah.
Okay, let's look at number 12 on page 440. Everyone there? Okay, it says 2/3 and 6/9. Okay.
No, I ask you a number.
10.
Number
I don't remember.
10.
Let's look at this one anyway. Okay, let's look at another. This one is easy. We'll do it anyway. Let's do it anyway.
Okay.
It says determine if the fractions are equivalent, if they're equal, and show your work. The first one is done for you. So you had to cross multiply, okay? I'm going to change the color here. You had to cross multiply. That means 2 times 9 and 3 times 6, and determine if they're equal, if the fractions are equal that way. So if I do this, 2 times 9 equals
18.
18. And 3 times 6 equals
18.
18.
It's cool.
Yeah, when we have just one number, how can I do that?
Where's there one number? Show me.
Is that like page 429, number 14 and number 12? We have number 12, just number 7, and number 14, 12.
Okay, let me finish page 440 and then we'll go back and talk about that, okay?
All right.
Okay, so this is problem 12. I should have put that up here for you. This is problem 12 on page problem 12 on page 440. And it tells us here when we cross multiply that we have equivalent fractions because 18 equals 18. There are going to be problems, and let me find one really quickly for us. Let's look at number 4, okay? Number 4.
Okay.
Okay, number 4. On page 440. It says 3/6,
5/12.
3/6, and 5/12.
30.
Okay, we're gonna cross multiply, remember?
Yeah.
Yeah.
So we gotta start with, let's start with 5 times 6. What do you get?
30.
30.
30. And what about 3 times 12?
36.
36, exactly. Are they equal?
No.
No, they are not equal. See that equal sign with a slash through it? That means they're not equal. Okay, so you will get examples of both.
Okay.
Okay, don't expect them all to be equal. They're asking you to determine if they are or not. By showing your work, you can figure it out. Okay, by doing that multiplication.
Mhm.
All right.
Okay.
Any questions about that page?
No.
No.
Okay,
Yeah.
page 441, we had to reduce and raise a fraction. Reduce and raise a fraction. Let me see, page 441 and 442, reduce and raise. Do we know what those terms mean in general? If I said reduce something, what does that mean? Reduce, I'm gonna write it down.
Lower terms.
Yes, reduce. It means lower, right?
Yeah.
Lower, take it
Yeah.
down, right? Lower terms, right? And then the opposite of that would be, what's the opposite
Higher.
of taking down?
Higher.
Yes, higher or raise, right? So when we're talking about fractions, if the direction says reduce the fraction, that means make it smaller. If the direction says raise the fraction, it means make it,
Higher.
yeah, bigger. Take it higher, make it bigger. So let's look at page 441. Let's look at an example. Okay, if I gave you, can I erase this?
Yes.
Okay, let me clear it. If I said 20, I'm looking at number 5. This is number 5 on page 441.
Okay.
Okay, it says 20 divided by 25. 20 divided by 25. And it says reduce this. What would I do? What do I need to do?
We'll make it lower.
Yeah, how do I make it lower?
Divide.
Division or multiplication? That's the question.
Division.
Division. Exactly. When we divide, we can make things smaller, right? So I have to find a number, the highest number divisible by both of these numbers.
4, 5.
We're gonna do the 20 divided by 5.
5.
5. Somebody said 5,
Yeah.
Yeah.
right? So 20, if I said 20 divided by 5, I know 5 can be divisible by both of them,
Yeah.
right? 20 divided by 5 is equal to
4.
4. And 25 divided by 5 is equal to
5.
5. We chose 5 because that's the highest number that can go into both 20 and 25. Whenever you want to reduce, look for the highest number divisible by both of them. Do you know why?
Why?
Because if I find the highest number that I can divide into both of those numbers, then I can get the most reduced answer in my fraction.
Oh, okay.
Okay?
Okay.
And I'll give you an example. Can I erase this one?
Yeah.
Okay, I'm going to ask you to mute your microphones, please. So there's some background noise. I don't know if it's affecting anyone. Okay. So we have, all right. If I said 10 divided by 20, and I want to reduce. Okay, reduce this fraction. 10 divided by 20. And I say, okay, what's a number divisible by both? Maybe I said I know 2 can go into both of them. So I'm going to divide by 2.
5.
10. Let's say I chose 2 because it's an even number and I know it goes into both of them. 10 divided by 2 is 5. 20 divided by 2 is 10. Look what happens in your answer. You can unmute your mics. If you have any questions, unmute your mic. If not, you can continue to keep it on mute, whatever you like. So I divided 10 and 20 by 2, and I got in my answer 5 over 10.
Over 10.
Is that the most reduced answer, or can I reduce 5 over 10 again?
Again. Yeah.
Again, look what happened. 5 over 10 can still go down more. I can still reduce it more.
1
So
over 5.
now, instead of doing this problem in 1 step, I have to do it in 2 steps. Do you see the problem?
Mhm.
I don't want to do that. I want to save myself some work. So I get 1/2, but it took me 2 steps to figure that out. Here's what I should have done. Are you ready?
Mhm.
Can I erase this?
Yeah.
Okay, watch. I'm going to erase that. I don't want 2 steps here. If I don't need it, we're going to divide by a different number. What number do you think I should have divided by?
10.
10, exactly. If I divided by 10, now 10 divided by 10 gives me the most reduced answer here, 1. And 20 divided by 10, 2. So now instead of 2 steps, I solved it with 1 step. Why? Because I went with the highest possible number I can divide them by. Does that make sense?
Yeah.
Yeah.
Okay, so always look for the highest possible number we can divide by.
Okay.
And that's just one thing I wanted to point out with reducing fractions.
Okay.
Can I give you one to try now?
Okay.
Yeah.
Can you
Yeah.
try number 6
Mhm.
on page 441? Number 6. Number 6 says 12. Let me pick a different color here.
I did this page, same step they do it, and then number 1.
Oh, you reduced it and then you cross multiply to check it?
Yeah.
Okay, yeah, that's fine. Yeah. The reason you cross multiply again, just like the previous lesson that we did on page 440, the previous page, the reason to do that, excuse me, is just to double check your answer.
Oh, okay.
Okay? It's always good to double check your answer, especially in math.
Yeah, okay.
Okay? So we have 12 over 36. Who wants to try to give us an answer for this one? What did you get?
I divided and 12.
And why did you choose 12?
Mm. Because when 12, 36, 12, it take me 3.
Yeah, it gives you the most reduced answer, right?
Mhm.
And that's the trick. Sometimes the numerator can be the highest possible number to divide by. If it is, great, because guess what you'll get in your answer? A 1. You can't go down more than 1.
1.
Okay?
I
Does that
divided
make
by
sense?
6.
Any
I do-
questions about that?
I'm asking you, I divided by 6. Is
I
that,
do.
is that
Okay, I'm going to show you if you divide by 6. So we have 12 divided by 12. We got 1. And what's 36 divided by 12?
3. 3.
3. Can I reduce more than that?
No.
No. No, we cannot. So always ask yourself, can I divide by the numerator itself? If you can, then that's going to give you your most reduced answer because you will get a 1.
Mhm.
Okay?
Okay.
Now let's go back and do what Fatima K said. She said, I divided by 6.
6.
Okay,
Me
let's
too.
try
I
that.
do divide by 6.
Okay, let's try that. Okay, good. Let's try it. Divide by 6. What's 12 divided by 6?
2.
What's 36 divided by 6?
6.
Is that reduced as much as we can? Is that simplified as much as we can?
No, we can do it
Exactly. By what?
by 2.
By 2, right? Do you see what I mean? Now I made 1 step into 2, and that's okay. That's okay, as long as you realize that you can still simplify it.
Okay.
Okay, as long as you see, okay, 2/6, I can still simplify it or reduce it more, and you get the correct answer, which will still equal what we got earlier, 1/3. Okay, let me reduce my screen so I can,
Miss Mariam,
yes,
when we choose the number and multiply it, I'm sorry, we divide it, the first number I see the same all time, right?
I'm sorry, one more time, when we
divide the number to like make reduce, the first number was same. So like always it's the same, like always we put the same number. I'm sorry.
I'm not sure I'm understanding 100% the question. So like the first number, always you divide by the first number?
Yeah.
No, it's not always going to be the case, Simona. Here,
Okay.
I was able to divide by 12 because 12 is a factor of 36 as well. So I was able to.
Okay.
Okay.
Because,
But
this-
sometimes, no, you have to find a number that's divisible into both of them, and it may not be the numerator. It's not always the case.
okay.
Yeah.
Because the first problem we got 10, it's the same. We put the same, and 12 is the same. So 1/3 or over 2. So I want
Number
to make
12?
sure just we put the same number.
Yeah, you can divide by the same number as the numerator. That's fine. If it's
Okay.
divisible by the denominator, you can use it. Yeah, if it's not, then you can't. For example, I'll give you an example. Ready? Let me clear this. Look at number 10. Number 10 on page 441. It says 10/14, and it says reduce that or simplify. Another word for reduce, simplify, is simplify. Okay? Okay. So 10/4, for example, here, guys, I can't say divide by 10. I can't.
Yeah.
Right? 10
Yeah.
does not go into 14 evenly. So I have to pick a number, the highest number that can go into both 10 and 14, which is what?
2.
2. And now what do we get?
5/7.
5/7. Can I reduce 5/7 anymore?
No.
No. That's it. That's my final simplified answer. Most reduced answer. Okay? Great. All right. I'm just giving you examples. So whatever pages I go over now, please try to finish those pages.
Okay.
And a lot of them you did them already. I made page 440, it was due last week. So you may have done them already. And if you did them and you didn't send me a picture, please send me a picture so I can give you credit for it. All right. Page 441. Okay, we just did that one. And now what about raising? What did we say raising a fraction was? This is page 442. What's raising a fraction? Do you see that? Raising. We said, what does raising mean? Take off or take down?
Bigger.
Yes. So remember, we said when we reduce, please write this down. When you reduce,
Low.
you are dividing. When you raise a fraction, you are what? What's the opposite of that?
Multiply.
Multiplying. Very good. Write that down, please. Okay, so page 442 is about raising fractions, so making them greater. Usually when you have to raise a fraction, as you see on page 442, they would give you one fraction and the denominator or the numerator of the other fraction. So that way you know what you're supposed to multiply by to get the missing one. I'll give you an example. Look at number 5 on page 442. Okay, I'm going to clear that. So number 5 says 5 over 8 equals question mark for the numerator of the other fraction over 24. Now I know because they gave me a clue to go from the denominator of 8 to a denominator of 24. What did you think they have to multiply by?
3.
Yeah. I know if I say 8 times 3, I get 24. So whatever I do to one, I have to do to the other one. So if I multiplied 3 by the denominator, I must also multiply by 3 in the numerator. What's 5 times 3?
15.
15. So I'm going to erase that question mark, and I'm going to put 15. Does that make sense?
Yeah.
Whatever you multiply or divide by, you have to do it for both the numerator and the denominator. You can't change the number.
Okay.
Okay, the number you multiply or the number you divide by has to be the same for both the numerator and the denominator. Questions about that?
No,
No.
thank you.
Okay, so page 442 is another one that I want you to try. And the last page that we have on this lesson, lesson 5, because I don't want to keep us here too long. I know it's been a while. So the last page is page 443. And this one, you're comparing fractions. Remember when we compared whole numbers, we were talking about greater than, and let me delete this. We talked about greater than, less than, or
Yeah.
equal to. Remember that?
Yeah.
Okay. So looking at fractions, we can do the same. We can do the same. Look at number, let's look at the example on the page. Do you see the example? It says compare 3/4 and 2/3. Compare those, and you have to write whether it's greater than, less than, or equal to. Okay. In this case, we're saying is 3/4 greater than, less than, or equal to 2/3. Okay. And the reason, not the reason, sorry, but the way we can figure that out is by cross multiplication. Okay. Just like we learned 2 pages ago, about 2 pages ago, maybe 3. To cross multiply, we multiply the numerator of one fraction by the denominator of the opposite fraction. So here we have 3 times 3, which is 9, right?
Yeah.
And then we multiply the same thing, the denominator of of one fraction by the numerator of the opposite fraction. So here we have 4 times 2, which is
8.
8. We have 9 and we have 8. So numerator of the first fraction, we're going to say the numerator of the first fraction is 9, it says. And look at the results. Since 9 is greater than 8, the first fraction is greater than the second fraction. Does that make sense? Because we started with this fraction first. We multiplied 3 times 2. I'm sorry, 3 times 3. We're going to call this the first fraction. So 3 times 3 gave us 9, which is greater than when we said 4 times 2. Therefore, I'm going to erase a lot of this here. Okay. Therefore, when I want to write down which one is greater than or less than, I'm going to go with the first fraction. Why? Again, because when I started by multiplying the numerator of this fraction first, this one. 3 times 3 gave me 9, which is greater than when I multiplied 2 times 4. Does that make sense?
Yeah.
Okay, let's look at another example. They did number 1 for us, but let's go over it anyway, okay? I'm going to clear everything here. Number 1 says 4/5 divided, no, not divided by, we're going to compare it to 5/7. Okay, what do you think for this one? We're going to start with this fraction first, right? 4 times 7 equals
28.
28. Good. And then we're gonna do this side, right? And we're cross multiplying, remember.
Mhm.
We're cross multiplying. 5 times 5 is,
25.
oh, I took the pencil away. 5 times 5 is 25. So again, ooh, sorry about that. 25. So again, we're starting here. When we did 4 times 7, this is gonna be our first fraction. So 4/5, would you say is greater than, less than, or equal to 5/7?
Greater than.
Greater than, why? Because why?
28.
28.
Yes.
Other one, 20.
Greater than
That's it.
25.
Mhm. Very good. Do you want to try one more?
Mhm.
Please.
Okay, let's do number. Let's do number 7.
Okay.
I'm trying. Hold on. Let me find one with a different kind of answer. So give me just a minute. Let me find one with a different answer. Okay, let's look at 6. Number 6.
Mhm.
Try
It's
it and tell me what you get.
Yeah, it's equal.
Equal. Very good. Why? How did you know?
When 8 times 5, 40, 10 and time 4 is 14 is equal.
Equal. Very good, because it's 40,
Mhm.
and this one is 40. Very good. So we would say in this case that they're equal.
Mhm.
Okay. How about number? Number 8? Did we do 8?
Number 8.
No, we didn't do 8. Go ahead. Try number 8.
5 times 8. 9 times.
This is number 8 on page 443.
Less than.
72. 5.
Less than.
Less
5.
than.
Yeah.
How did you know it was less than? Did you have to do any math?
Yeah, multiply.
What if you didn't? Look at the denominators here. They're the same.
Oh, that's him.
Yeah, so really all you had to do was look at the numerator, right? 5 is less than 8. So we just had to do that.
Yeah.
Does that make sense?
It's easier
Yeah.
than the other one.
Yeah, it's easier because the denominators in this case are the same. So we can forget about them for a minute and just focus on the numerator and which one is greater or which one is less than, and we can figure out the symbol. Remember, this symbol means that it's eating the bigger number. Okay?
Okay.
Any questions about what we've been over today?
No.
No, thank you.
I'm gonna ask the question, and I just want to cover it really quickly before before I let you go. She said on page 439, if we look at, for example, number 12.
Yeah, 12
Okay.
and 13. When
Yeah,
we have
it says change each whole or mixed number to an improper fraction. Okay.
Okay.
This is page 439, number 12. And it says just 7. Whenever you have just a number, put it over what? What do you think?
1.
1, exactly.
Okay.
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 Anytime you have a whole number and there's nothing under it and you want to make it a fraction, make it over 1. It's not 100% of the time. And when we talk about adding and subtracting fractions, I'll show you when this is different. Okay, but for now, just make it over 1. Okay. So this would be 7 over 1. What kind of fraction is that? Proper or improper or mixed?
Proper?
Is it?
Is that
What's
proper?
greater?
It's
Yeah,
a mix.
improper. Yeah. Because the numerator is greater than the denominator. Okay.
Okay.
And now it says you have to change each whole or mixed number to an improper fraction. And that's it. That's all we have to do for this one.
All right.
Does that, let me just double check while you're here that I did it right. 439. I think that was the right way to do that. For number 12, we said. Yep, that's all they wanted for this one is the improper fraction form.
Okay.
Okay.
Okay. Thank
Questions? No questions?
No, thank you.
Okay, thank you so much for showing up, and I appreciate it. I feel like this was more closer to what we had 3 months ago in class, right? We're,
Okay,
we're,
thank
we're
you.
communicating, it's back and forth, we're doing examples
Yeah.
together. I really enjoyed it.
Yeah,
And
me
hopefully
too.
we can do it again, maybe in the
Okay.
middle of the week, so we can finish off the lesson and maybe do some review of everything we've learned on the weekend, next weekend, because we'll be done like a couple days after that.
Okay.
Inshallah.
Okay, but I will let you guys know on Remind, okay?
Okay.
All right, ladies, if you have any questions, let me know. And remember to send me pictures, please, up to page 443.
Inshallah. Thank
All
you
right,
so much.
ladies, take care.
Thank you.
And happy Mother's Day if you're
You
celebrating.
too.
Thank
You
you
too.
so much.
Bye-bye.
Take care. Bye-bye.
Bye.